All right. Welcome back, super friends. Hope you're doing well. We are here once a week. If this is your first time tuning in, welcome. Thank you for tuning in and checking out this stream. I do these once a week on Tuesday evenings, usually at about 10 after 8 in the Eastern Standard Time Zone. And we hack on Haskell stuff and functional programming and general things like that. And so far we're in the middle of a project right now. We're making a, there was an old game in the 70s called Star Trek. It had many clones and variants like Super Trek and such. And we're building one in Haskell. It's called Lambda Trek. So creative, I know. And this is what it looks like so far. If we could just boot it up here. Lambda Trek. Boom. So we're in the middle of implementing a dialogue system for the game. Kind of my own little, I don't know if it's that novel, but I think it's pretty cool. So the idea is we'll have like different characters from your bridge who will be able to talk to you and like tell you about different aspects of like what's happening in the game simulation. You can put in your commands like move to 1-1 or 12-12. Yeah, we have some little bit of minor like command parsing error handling. So we try to move like way outside the sector, it'll be like, no, you can't do that. What we're going to try and work on this week, and what we started working on last week, is using this dialogue system to report the collision detection with this little thing here, which is a star. It's supposed to represent a star. And so we want the helmsman or the helmsperson there to basically say, like, look, Captain, there's a star there. I can't move there. And so we're going to continue on with that. Let's see here. Okay, yeah. So I'm going to just escape out of this, and we'll get to the code. So I'm going to open up Lambda Trek, and I'm going to first try to tackle, I guess, the formatting. It was the one thing I wanted to, that was kind of bugging me about this so far. And right now, it is, the way we're constructing those dialogue lines is by stacking together a bunch of widgets, text widgets, horizontally. And they are right here on this line. And they are filling in horizontally the whole width of the containing widget, which is that scrolling area. And I think that's the way they're supposed to work. And we spent a little bit of time last week trying to, like, see if we can get rid of the, like, padding or whatever. Maybe there's, like, some padding or filling or whatever to make them all kind of line up and stack to the left. I haven't done any research on whether we can actually do that with Brick, but I'm going to try this week, I think, just seeing if we can go down to raw VTY and getting... and like doing our own text rendering for those strings. That way we only have one text widget in there, and we can format the text in there we want. I just want to keep the coloring available there for the different crew members, so it kind of pops. So you know, if you're reading something from Tactile or Helm, you can just kind of like color scan your eyes. You don't have to read every single line like too deeply. Any hoozle. Haskell VTY library. So I believe VTY is the underlying library behind Brick. So it's already a transitive dependency. We won't be pulling anything extra in by using it, I believe. Yeah, VTY. So under here, VTY provides interfaces for both terminal input and terminal output. Input to the terminal is provided by to the VTY application as a sequence of events. Output is provided to VTY by the application in the form of a picture. A picture is one or more layers of images, and image values can be built by the various constructors in graphics.vty.image. Output can be styled using attr, attribute values, in the graphics.vty.attributes module. That's kind of a high level thing. We don't really need that to zoom out. I just want to figure out how to do strings and combining strings together, VTY strings. Okay, so string def adder with 4-color red. This text will be red. That sounds good. String. Let's see how we can, if we can combine those together. Okay, they create images. And images, how can we combine them? A horizontal span of text. Okay, something like that. We have semi-group. Okay, so we should be able to append them together. Alright, let's see if we can make this work. Our crewmate and our message. Let's import, what do we need? Graphics.vty.image. I guess so. Yeah, looks like it. Okay, cool. Delightful. Import. Qualified. Data. Graphics.image or graphics.vty.image. I will import it qualified as VTY. Okay, so now we need to create that string image thing. And then I wonder if Brick has a way for us to render that using Brick's widget, like stuff that in a widget. There we go, raw, that's what we need. Okay, so we build our raw image from VTY and then we're good. Okay, dialog stir, I'll call it. And then we use raw, dialog stir. Now we're good to go there. Okay. So dialog stir. We can construct our image using string and some of the color stuff we were talking about. And then we should be able to do that. So let's just go with the string vty.string crewmate. I will do the coloring in a second pass. vty.string crewmate. And vty dot string space with vty dot string message. Oh, right, we need to convert that to a string. Crewmate text. Crewmate. That fixes that one. Message. Good. Match expected type. Attributes.adder with actual type text. The first argument of vty.string. Oh, right. See, it takes an adder there. Oh, they have a certain combinator for that. Interesting. We'll try that in a moment. Let's figure out this one. So we need adders for those. Do we have like some basic... def adders. Def adder, okay. vty.def adder. And over here. Oh, it's a different module. Okay, that's fine. Fix that in a second. vty.def adder. And we'll fix that by importing this adder module qualified as well up here. Graphics.vty adder as vty. Oh, attribute. Attributes. Some little minor inconsistency there. Calls the type adder, the module attributes. Why don't it just call the type attributes as well? I don't know. Okay. So these all have to be Haskell strings. For reasons. We might need some encoding. Or just be very careful that we only use basically ASCII characters. So we could just try it with pack for now. So we gotta add data.text. We already have that. Where are we? There we go. Unpack that to a string. I'm just going to comment that out for a minute. Let's get our builder going. With our file watcher. Boom. Okie doke. So it compiles. Let's reload our application. We'll see how it looks. Okay. So we're getting somewhere with it, maybe? Let's fix this. So it's taking it as a string literal. That's probably why it's not throwing a type error there. That's cool. Let's try our VTY combinator there to construct this thing. There we go. That's looking better already. We're even getting like maybe a double space there. Cool, so that horizontal combinator, maybe we don't actually need this string part middle. Get rid of that whole thing. And then we can figure out the color bit, and we're good to go. Awesome. So, I don't know, if we do this with raw image stuff, we're probably opting out of word wrapping for this, I suspect. Okay, well, we can't get any smaller than that anyway. Interesting. Cool, cool. Might not be a problem. Could be a problem, not sure. Maybe, who knows. Okay, so color. Styles, no. For color. That's what we want, I think, right? For color. You gotta do. Okay, so we have predefined ones, that's good. I guess we go vty.width for color, vty.el. There we go. Okay, that looks a lot better already. So let's just make that yellow come back from the crewmate type. So this will be crewmate to vty dot color. Almost what we had before. And then let's bring that whole expression into there. then we'll pass crewmate in there. What do we got? Oh, we need adder, not. Wonderful. Super lovely. Oh, I love it. It's great. Ah, perfect. Okay, so now we can do the thing that we wanted to do with movement stuff and the air collision, and having Helm tell us what the problem is, why we can't move to the spot with the star in it. Okay, so let's create a commit for this. Can we clean that up a little bit? Does it need any... Bring it over a little bit. Yeah, that's okay. Yeah. Like this, it's fine. Yeah, that's good. Okay. Okay, so when applied, this change will render the dialogue text as a V2I image. Gives us more precise control over text layout or dialogue lines. Quick. Okay, next thing we gotta do. Let's get rid of all that junk crew data that we kind of created and dynamically add one when you try to collide with a star. So the app startup is where we kind of initialize the game state, the initial game state. So I'm going to go to the state module. There it is. So this will be initially empty. Maybe there'll be like some like welcome to whatever. Welcome aboard, Captain kind of thing. Okay, and then in our simulation, we handle the engine move. So here, we'd like to have different dialogue options for the different objects we're potentially colliding with. So, I mean, we could just do this like with an if, collides with stars, then game state with our message, else if collides with enemies, then game state with our other message. Otherwise, update the ship. That could be fine. It's not too bad. Just flip that off. If collides with stars. And then game state, and we're going to set the we'll use the over. Not ship. Game state dialog. And I think we'll use the over operator to update that. We'll append our dialog message to it. Yeah, so we get in this hole, we get a function list of dialog to list of dialog. We can even make that a function. Yeah, I almost want to make that a function, but I'll refactor that out in a minute. Let's just make this work. So we will go with our dialog message. Something. And we will... if we cons it onto the head of this list, I think that means that the messages will appear at the top. And I think for this widget, we want them to appear at the bottom. Let's just go with that for a minute. What did I call the type for dialogue? Oh, I just haven't imported it. Okay. Import Lambda trek emulation dialogue. So that will be helm, and the message will be Captain. That would take us directly to the star at blah blah blah. We want like a text, data text. Text dot. Is text dot show x. Yeah, no. Print, no. And comma x.pack. Go y, close parenthesis. Okay. Got a little here. I think we need some overloaded strings up in this business. There we go. Okay, let me just have some not used name stuff up for the moment. Yes, okay. And some minor things we pick up. Okay, we can move some parentheses around. To avoid some dollar signs. Try call apply. Cool, let's see how that looks. Soar star. Oh, move. Where did I put it? 1010? Yeah. Try it again. Okay. Okay, else if then else. And then it collides with enemies. Enemies XY. Something like this. Captain, we would collide directly with the enemy ship at blah blah blah. Okay. And let's update the state to have a pretend enemy ship for the moment. Sector. How do I got an enemy here. Okay, well, we're gonna have to define a little bit about an enemy. Actually, no, let's not do that. We're getting a little too advanced here. This change. Okay, so we got that working. Good. Let's commit that. Well, first let's clean it up a tiny bit. I'm gonna add a little helper dialogue function that could just add some dialogue to the game state. just so we don't have this like update syntax in a couple of places, because that's going to be such a common thing. Add dialogue. We could take a crewmate, some text. We'll take a game state. Crewmate some text and we'll turn it into a game state. And we'll do that. And then we'll just steal this. And that'll equal something, and da-da-da. Construct the dialogue. Crewmate and message. Alright, put game state and here. How to make this work. Okay, and then we need a import Lambda trick. Wait. That's nice. Any problem with that? What is the problem with that? Oh, circular import. Okay, so lambda trick.state imports dialog, which imports state. Okay. So we can move this function up to game state. That's because game state has the dialogue type in it as well. Let's go there. And then our simulation update already imports that, so that's all good. In fact, I don't think... Well, we might need it, yeah. We might need to still import dialogue, because now we can replace this. Add dialogue. The game state. Helm. And then our text. That's nicer. state. Okay, it's a little better. See if we can just organize it a little better. Yeah, that's all right. Sweet. Okay, that looks pretty good. So let's create a commit for that as well. Just do a quick little review. Yeah. Good. I like it. Okay, so this will, when applied, this change will emit dialog from Helm when colliding with objects. If the player tries a move command in a sector, that would put the ship on a star or enemy. Helm will tell the player why they can't complete the command. Cool. So we got the basics of our dialogue system motoring along. We have engine movement, and we have collisions with with other game objects. So let's flesh out enemies next. I was about to do that, so why not go that direction? And keep the velocity moving. Okie dokie. Let's go into simulation sector. Okay, there's our enemy type. Let's create an enemy module. Here. Mm-hmm. You should have it now. That's odd. The right place? Yeah, simulation / enemy. For Lambda track.simulation.enemy. Yeah. Oh, sorry, up here. Handle engine move. I wasn't paying attention. And board Lambda track simulation.enemy. Perfect. Okie doke. So we're going to need a position. A position for this enemy. Now, of course, we won't be able to construct enemies at any integer position. Remember, they got to be able to be in a sector. So this position can only be within the sector bounds. So we'll need some kind of constructor. We could either like make a smart constructor and use the smart constructor pattern here, or we could just trust ourselves to not construct enemies in the wrong place. Yeah. Maybe. Yeah. Yeah. Let's see. Let's leave the smart constructor out of it until we feel like we actually need it and we would get some value out of it. Yeah, let's just do it that way. Okay. So enemy simulation. So we got the X and the Y of it. So we can actually fill in with collides with enemies now. For that, let's put an enemy into our empty sector. And we'll put a test enemy at 8, 3. Okay, we'll do that, and we'll get a, well, I think we'll probably have to render them. Yeah, so the sector build tiles. So we'll need to We'll need to update build sector tiles here to handle the enemy ships and not just stars and the player ship. So in order for us, like, it wouldn't be the worst thing in the world to do like several passes over top of these tiles, because like really it's not that big of a structure. This isn't a very fast game. But if we could do it in one pass, that would be great. So in this function, we are folding over the list of stars. I think what we could do is go over the set of positions in a sector. So the indices, so X and Y. And for each position, we could search in if there's any object in our game state that matches that. So we could check stars, we could check enemy ships. And that should be fast enough. Or we can make another binding. This. I'll call it add enemy instead. Enemy X and Y, we'll set it to enemy ship and tiles. Yeah, we gotta create the fields for that and the type for that. So, tile. Enemy ship. Enemy ship. So far, so good. And then we just need the fields for this. So we need template Haskell. And Import lens.micro and make fields enemy. Lens.micro.th. I call it position X. Did I name the fields a little weird? For some reason it's not working the way I lens.micro. It's probably, there's a couple of different ways of constructing lenses that use different conventions for the field names. And it's bothering me that I'm not seeing what I want here. Okay, make lenses, I think, use the underscore approach. Right, generates X, Y. And make fields, generates overloaded lenses. This lets you deal with several data types having the same fields. Okay, the convention I think is you gotta like lowercase the constructor name here. Okay, that's the one I actually want. So I just gotta remember to use that convention consistently here. I might want to go through my other make fields definitions and do that in a separate pass, just to make sure I'm doing this consistently, and then fix up all of those use sites. So we need to allow a couple of type classes for this to work. Language. Let's grab type classes. Probably functional dependencies. Yeah. And then enemies. I think that, but no, sector is in sector. Enemy ships. Beautiful. Okay, let's see if that worked now. We should have a rendered enemy ship. And we do. Bang. Okay, and now if we collide with it, 8-3, we technically shouldn't be able to move there. So, what we're going to have to do is implement that collision detection now. Okay, so we get collides with enemies. It's a list of enemy, an X and a Y. So what do we do if... Find an enemy with an X and Y that matches our X and Y, basically. Okay, that's the one we're going to use. I think I should be able to use list without that. Unqualified. I'd sort of prefer to use list unqualified, but just because it's so common. Let's put a tick on that. So avoid name shadowing. Okay, so our find function takes some in enemies. So we need applied with enemy. And so if we don't find such a collision, we'll return false. Otherwise, true. We did collide with something. So let's just implement collides with enemy. Let us return a bool. And this will be a simple equation. Enemy position x is equal to x prime, and enemy position y is equal to y prime. Ow. Okay, yeah, actually it is good practice to import qualified. We'll do that. Perfect. Now, let's run our game. Move to A3. Perfect. Captain would collide direct. We would. Oh, let's fix that string. It should be we would collide directly with the enemy ship at A3. But yeah, there we go. Okay. Wonderful. And if we try to move into the star. Yeah, okay, so it is, because we are using cons, it is coming in from the top, as you can see. That's not too bad. We could actually... Yeah, actually, I should kind of like that. Yeah, because that means, like, if we want to scroll back, we can just scroll down, but it kind of simplifies things. Because otherwise we've got to invert the state of our scrolling and do a bunch of tricks for that. So I think having it come in from the top is actually good. Oh, interesting. I don't know if you can see this on the screen, but we just got a little bit of break between our Unicode widgets for some reason. Not sure why. Maybe it's like just my font or something. I don't know. Interesting. Okay. Well, that's cool. So let's create a commit. And just review. Alright, so we added the enemy collision detection and fixed the dialogue there. Added the enemy module, so we gave enemies positions. Let's see, we add the enemy tile. And we just added, yeah, the enemy ship tile there too. Cool. Yeah, that looks good. Add basic enemy ship. Also as enemy tile, ship tile. Collision detection, player ship. Booyah. Alright, this is starting to come together a little bit. Alright, how are we doing for time? 9:22. So that means let's see, one thing I want to fix actually is the command input area. Notice how like I put lowercase here, but like all of our command parsing is based on uppercase. So either we should update our parser to accept lowercase versions of this as well as uppercase versions, or we should just make this always convert all of our text to uppercase. Which I think might be the easier way of doing it. Okay, so that happens over in... There's a couple places. If we wanted to do through the form, through our command palette form. Game state command input. Command palette. No. Let's try game state. So the widget takes a lens into our game state. Is basically how that works. And is wired up by brick. So here, let's see. In new form, when we construct it with muck form, we have this edit text field. This here is the lens that goes into our game state. That I guess edit text field uses for setting the value of it. And it sets it directly. So I don't know if there's a way for us to intercept the values there to uppercase the string. Let's see, what can we do? We can define our own setter function lens for that particular field. Sounds pretty complicated, probably is. And we could... Well, I guess when we go to dispatch that command, we could upstring it before passing it to the parser. We can upcase it. That might be the easiest fix for that, to make that work. Okay, so when the user presses enter, we get the contents of the form. And... oh, that doesn't happen there. Update simulation. There we go. That's where it happens. So yeah, we could basically do it right there. I think text has a function for uppercasing. Upper, to upper. Okay, so that's probably the fix right there. Boom. Yeah, perfect. There we go. Wunderbar. Let's commit that. Convert command input to uppercase. Before parsing. Done. Okie doke. Okay. So the next thing we need to get working is, let's see. We would like to battle some ships. I think is probably what we want to do next. Now that we can move around a sector, we can avoid colliding with things. Next thing we need to be able to do is be able to fire phasers at the enemy ship and blow that sucker up. All right. What else do we need? We need energy. Energy management is a big part of the game. So our ship, from almost all of our actions, consumes some amount of our ship's available energy stores. And that's a resource the player manages throughout the game. So actually, let's do ship movement and make it consume some energy, and we'll display the amount of energy we have in our ship in our right-hand panel and get the that widget going as well. The ship status widget. Okay. So let's go to the ship module. Yeah, let's get rid of that and make fields. Language. Temperature Haskell. Import lens.micro.th. Make fields for the ship. Call this position X. Position Y to be a little bit consistent with how we did it for the enemy ship. And then, of course, we need a couple of more language extensions for fields. Language. Functional dependencies. Language. Multi-param type classes. A couple of places, yeah, where we gotta update that. So we used that in simulation sector. There. convert this to position X and position Y. Oh, it does. It does. Because we're only... Yeah, we're probably getting qualified. Yes. Okay, now we're getting name collision issues, which is super fun. How do I want to resolve that? How do I want to resolve that? It does. So the problem here, the error that we're getting, is this no instance for house position Y ship. This class here is generated in the template Haskell from this make fields call. And that's why we also need functional dependencies and multi-param type classes, because the implementation of that gets generated uses those language features so that we can have this kind of like generic-ish position Y lens that uses this has position Y instance for various types. All right, so position Y now, we can have multiple types that use this lens, and through type class instance resolution, it figures out which implementation it will use. But I'm just getting name collision issues. It's the way we import ship qualified here is not pulling in the instances, which is why I'm trying to like different things here. If I take off the qualification on it, will this not collide with anything and be okay? No. And now we get an ambiguous incurrence. Position Y. It could be the enemy ship position Y. Or the player ship position Y. And that kind of defeats the purpose of the whole thing, doesn't it? It's almost like we want to have the concept of position lifted out of these types and these objects into something else, so that we only have to import it from one place without collision. If I put the collision stuff back, or if I put the qualified imports back, it'll just be somewhat ugly. Which might not be the worst thing. Simulation. Ah, okay. And we'll do, alright, well, for the types here. And then we'll just fix all the places. I don't think that one's quite a problem. Yeah, we gotta use ship.ship there. Well, unless I pull in the constructor. What's up? So we don't use anything from ship, we can just cover that up there. Yeah, I gotta figure out a way to clean that up. I don't like that. Anyhoozle. It works for now. Okay, so now that the ship has some of that stuff in it, it's pretty commit for all of this. Add field lenses for ship. And then we can go to ship and add energy. House. Yeah, there's a couple of places, I think, where we construct a ship and we have to pass a new bibbidi boop. Simulation. Oh, where is it? Game state. Okay, that's it. Right on. Super. We should start the ship with, say, 100 energy. Cool. And then here we have to fix that. So we can use over to get the ship. No, set was still fine. We just need to get the ship's energy from the game state. Now we need to import qualified. No track. Simulation. Ship. We get that energy lens. That's pretty ugly. Okay, so that works there. So let's create a tiny quick info widget to display our ship info in and show the user how much energy their ship has. Okay, let's look at the brick library. I believe it has some kind of table view. Yeah. Create a table with table. Sick. So, constructing a table with a list of widgets. The argument is the list of rows with the topmost row first. Each element of the argument list being the contents of the cells in each column of the respective row, with the leftmost cell first. Okay. And then we can configure the table with alignment rules for the different columns and such. Super. And then we can set row borders and column borders. Awesome. And then, yeah, that's pretty much what we want. Okay. So let's go to UI and create this widget. Right now, right is our info panel widget. So we're going to change this up here. Table. It's going to need game state. We're going to ignore game state for now. I just want to render a table with something in it. So we get a table n, and how do we turn that into a widget? Render table. Okay. That's in another module, is it? Yeah, databricks.widget.table, I guess. Brick.widgets. .table. Let's go. Barrel. So info panel needs our game state. I see. Probably easier just to take the form. Game state, name. Just ignore it for now. Render table. Table. We could do like energy. Ooh. Now those have to be widgets, so this should be text. I'm sorry, stir. Okay, sweet. There's our table. Let's make it not float in there weird like that and take up the whole space. Okay. So we configure it to have no surrounding border. Setting the different columns and rows. So each row's height is determined by the height of the tallest cell in that row, and each column's width is determined by the width of the widest cell in that column. This means that control over row and column dimensions is a matter of controlling the size of the individual cells, such as wrapping cell contents in padding, fill, and age limit or v-limit, etc. This also means that it is not necessary to explicitly set the width of most table cells, because the table will determine the per row and per column dimensions by looking at the largest cell contents. In particular, this means that the table's alignment logic only has an effect when a given cell's contents are smaller than the maximum for its row and column, thus giving the table some way to pad the contents to result in the desired alignment. Border drawing behavior can be configured with the API in this module. Note that tables always draw with join borders enabled. If a cell's contents has smart borders, but you don't want those borders connected to the surrounding table borders, wrap the cell's contents with freeze borders. All cells of all rows must use the fixed growth policy. Okay. So there's no way for us to make this kind of like fill the whole right panel there. So let's make it center at least. that should be pretty good. Good enough, at least. Okay, so let's get the ship's current energy out of the game state and render that. And oh, okay. We can just call it right on F. Oh, form state. All right, so this will be show of game state yep. Position X. Oh no, energy. We're going to have to import that. Qualified, Lambda, Trek, simulation, ship. I'm going to do my naming stuff. Yeah, I might need... parentheses around that there. Okay, cool. That should be good. And let's just check it out. There we go. There's our ship's energy. Sweet. Okay, so now we need to decrement that energy whenever we issue our move command. We're handling our move. So let's go and commit what we have so far. So when this change is applied, it'll add ship energy and info UI widget. Something like that. Okay, and then we can go to our simulation when we handle the engine move. In our else case, we actually have to set the energy minus, let's hard code something right now, like 2. Can't do that. But if we move to like 2.8, we subtract some energy there. Sweet. Okay. And that's that. That was pretty easy. Chicka-chow, chicka-chow. This would apply. This will decrement a fixed amount of energy from move. This should probably be a dynamic amount, or at least a configurable amount. So like moving, the further you move, it should have like maybe a cost based on distance or something like this, but it's fine enough for now just to get it working. We can figure out what the rules of that should be. But we're out of time this week for the stream. We're basically done here, so let's just review our commits. See if we need to like reorder anything or whatever. I think those are all pretty good. We'll push those up. So if this is your first time tuning in, thank you and welcome. I'm Agent Ultra, your humble host. And all of the code you've seen tonight, today, wherever you are, depending on your time zone, is on GitHub. Here in Lambda Trek. This is the Super Trek-ish, Star Trek-ish clone of an old game from long, long ago, written in Haskell. So you can get that there. You can also follow me on the Fediverse. I'm on the types.pl server at agentultra.com and a lot of other socials and things like that. So yeah, let's see if I can get my profile here. That's me, Agent Ultra at types.pl. So you can follow me there. You can go to the link above me and check out that website. There's a link to a Discord server. So if you're a Discord type of person, we have a channel there for this stream where you can tell me about your cool Haskell projects, or you can talk about anything you saw on the stream that you wanted to discuss but maybe didn't have the time to. Or of course, if you're watching on YouTube, because you're in a completely different time zone, you couldn't join us tonight, follow along there as well. So my usual schedule is again Tuesday evenings around 10 after 8 in the evening, and I do these streams once a week. So thanks again for joining me. Check out that code. Let me know what you think. I'll see you next week. May your types always check. May your monads be free, and I'll see you next time. Bye.